In this video, we're going to estimate a derivative using a symmetric difference quotient and then estimate a second derivative using a symmetric difference quotient. So first thing we're going to do, we want to find s prime of 3 t at 3. So we're going to estimate s prime of 3. Well, when you're using a symmetric difference quotient, that means you're using the points on both sides. So we're going to use here at 4 and here at 2. So what we're going to do is we're just going to find the average rate of change between those. So 18.2 minus 12.4 over 4 minus 2. And we need to make sure our points are lined up. We see that this is an increasing function, so we know our derivative should be positive. So this is going to come out to be 5.8 over 2, or 2.9, and now this was position in meters, this was time in seconds, so this is going to be meters per second. So I should have used an approximation here because we're approximating with a central difference quotient. Now the second part asks us to estimate s double prime of t at 3.5. I'm going to do this off to the side so we can still see our data. So if I want to estimate s prime of 3.5, what that means is, remember, this is the derivative of the derivative. So I'm going to use a symmetric difference quotient with my first derivative on points on either side of 3.5. So that means I'm going to do s prime of 4 minus s prime of 3. I'm going to use that because I already found s prime of 3 over 4 minus 3. Change in output over change in input. Now we need that other value. I've already found s prime of 3. We do need s prime of 4, so this will give us a little more practice at using a symmetric difference quotient here. Remember, I'm going to use the points on the two sides of 4. So I'm going to use this one at 5 and this one at 3. So 22.1 minus 15.1 over 5 minus 3. So that's going to give us 7 over 2, or 3.5 meters per second. Alright, we've got our values, s prime of 4 and s prime of 3. I'm going to move the paper a little bit now that we don't need that data anymore. So our s double prime of 3.5, let's see, we had s prime of 4 minus s prime of 3, so 3.5 minus 2.9 all over 1. So that's going to give us 0.6. And the units on this are meters per second, or if we wanted to consolidate that, 0.6 meters per second squared, so it's an acceleration. So that's how we use a central difference quotient to find a first derivative and then a second derivative.